Add polynomials. When we add polynomials, there are typically two ways that you can perform. The first way is you add horizontally, combining like terms. The second way is you add vertically, also combining like terms, but you identify like terms at the beginning. Let's look at how each method works. Number 1, we're adding ax squared plus 3xy plus 12y squared and 2y squared minus 6xy minus 4x squared. Identify like terms. If we identify like terms, we will see that ax squared and negative 4x squared are like terms. And then we have positive 3xy and negative 6y as like terms. Finally, we have positive 12y squared and 2y squared as like terms. I noticed that I use different marks to label them so that when I add them, I will be looking for the same marks for different terms. Let's add them. Ax squared plus negative 4x squared, that's 4x squared. Next, positive 3xy plus negative 6y, that would be negative 3xy. And finally, positive 12y squared plus 2y squared, that's positive 14y squared. Let's look at the other method, add vertically. When we add vertically, you're basically doing the same thing as we did before. Instead of labeling or marking different like terms, we are aligning your terms vertically based on the variable part. So I'm going to write the second polynomial in number 3 right below the first one, but I will rearrange them. If you look at number 3, r squared minus 3r plus 2. And the terms that we're looking at, to add them in the second polynomial, make sure that you align the variable that has the same degree right below the first polynomial, the corresponding terms. 4r squared also has a second degree, so you're going to write it right below r squared. And then negative 6r, it's a first degree, so it matches the second term in my original polynomial. Finally, you have the constant term 5, which matches with the constant term in the original polynomial. Once you align them, you're ready to perform the addition. So I simply add vertically. R squared plus 4r squared, that is 5r squared. Negative 3r plus negative 6r, that's negative 9r. 2 plus 5, that's positive 7. Objective B, subtract polynomials. Very similar to adding polynomials, we will also have two ways to subtract polynomials. One is subtract horizontally, the other one is subtract vertically. When you subtract horizontally, make sure you identify which polynomial comes first and which polynomial comes next. Number 5, 4x squared, 4x cubed plus 6x squared minus 2x from ax cubed minus 4x squared plus 3x. So in this case, we're subtracting the first polynomial from the second one. Therefore, the second one is the first polynomial that you should write. Let's copy the second polynomial. And we're subtracting this polynomial by the first one. Make sure you put them in grouping symbols. And now the next step will be getting rid of the grouping symbols. In order to get rid of the grouping symbol, we will apply the distributive property. Since there are no numbers outside of each pair of these grouping symbols, we could put an invisible 1. So for the first pair, I place a 1 there. For the second one, I also place a 1 outside. The benefits of doing this is it's very clear what you need to distribute. First part, we're distributing the positive 1. So if you multiply every single term inside by positive 1, you still get the same term. It doesn't change. And that's how you get rid of the first pair of grouping symbols. For the second pair of grouping symbols, distribute -1. So if you multiply every single term inside by -1, they're gonna have an opposite sign. -4x cubed, -6x squared, and positive 2x. And now it just simply becomes number 1 and number 3. We're combining like terms when we add horizontally. This time I'm going to highlight like terms. So we have ax cubed, -4x cubed. They're like terms. Let me change the color. -4x squared and -6x squared. And then you also have positive 3x and positive 2x. Let's combine like terms. Ax cubed minus 4x cubed, that gives you 4x cubed. -4x squared minus 6x squared, that's -10x squared. Plus 3x plus 2x, that's plus 5x. Number 7. What if we want to subtract vertically? Well, when you subtract vertically, the first thing to do is the same as before. You figure out which polynomial comes first. According to the description of this problem in number 7, the second polynomial comes first and you minus the first polynomial. To do it vertically, there is something that you need to do. But first, let's write down the second polynomial. When you write down the second polynomial, make sure that you align them right below the first polynomial. But when you do that, you probably notice when we are looking for the first degree, the second polynomial here doesn't have the first degree. So how do we deal with that? Well, we have to rewrite the polynomials in descending order, of course. X cubed plus x squared plus, and here we don't have the first degree. So one thing you could do is you could add a first degree. When you add a first degree, because it doesn't exist, we're gonna make the coefficient 0. And then followed by the constant term 10. And then, since it's a subtraction, what we're gonna do is we're gonna add the opposite polynomial and change the operation from subtraction to addition. So here is what we usually do when we subtract. For example, 10 minus 6. It's the same as 10 plus the opposite of the number that you're trying to subtract. We were trying to subtract 6, and the opposite is -6. So 10 minus 6 is the same as 10 plus -6. Therefore, it's the same thing here when we subtract polynomials. It's the same thing as when we're adding the opposite polynomial that we're trying to subtract. So I'm going to find out the opposite. It's very easy to find out the opposite. You simply change the sign of every single term in the polynomial. 4x cubed becomes -4x cubed. Make sure you align them correspondingly. And then positive 6 becomes -6. And you have to align it right below the 0x that we inserted into the first polynomial. Finally, -1 becomes +1. And you put it right below plus 10. And now we are ready to add vertically. X squared plus -4x squared, that's -3x cubed, x cubed. Next term, x squared plus nothing, that's still gonna be x squared. And then 0x plus -6x, that's -6x. And finally, 10 plus 1, that's +11. Number 9, remove the parentheses and simplify if possible. So for number 9, number 11, you have parentheses in your original expression. You could consider each parentheses as like a polynomial inside. All you need to do is apply distributive property to get rid of the grouping symbol and then combine like terms. For number 9, I'm gonna put an invisible one right in front of that grouping symbol, and then I'm gonna distribute this -1 inside. So let's perform the operation. First term, 5c, so you simply copy 5c. And then -1 times 4c, that's -4c. -1 times 2d, that's -2d. So this is what happens after you distribute. No more grouping symbols. Next step, combine like terms. The first two terms, they have the same variable raised to the same power. We can combine them by simply combining the coefficients. 5 minus 4, that is 1. So it's basically 1c followed by -2d. And you probably know that we don't need that coefficient 1 in front of the variable, so it's simply c minus 2d. Number 11. For number 11, if you place invisible 1 in front of each pair of the grouping symbols, you will notice that we simply distribute positive 1 into the parentheses. Therefore, we don't change anything. All you need to do is just get rid of the grouping symbol and rewrite every single term. There's no change other than removing the parentheses. Second step, just like what we did before, combining like terms. Identify like terms and preferably write in descending order. 5x squared plus 2x squared, that's 7x squared. 6x plus 2x, that's 8x. -5 plus -1, that's -6. Objective C, solve applied problems involving the addition or subtraction of polynomials. Number 13. The surface area of a cylindrical can is approximated by the polynomial expression, this one. Simplify this polynomial expression. We only have addition in this polynomial, so we identify like terms and then combine them. It's very easy to see that the first two terms are like terms, so we simply add the coefficients. 12.56 plus 12.56, that is 25.12, followed by the variable part r squared, plus the third term in the original polynomial, 25.12 rh. And then we cannot combine these two terms anymore because they don't have the same variable part, and that will be the end of simplifying this polynomial expression. Well, thanks for watching.